Okay, what I did was replace this 2-relay board, which only one relay was connected to here, and I made a 4-relay board. So I had a relay for each button. So I also have remote buttons. And I did have to make some changes, so there is some changes from this board to this one as far as the reset on these chips here. And so you can see here, I press the button, light comes on, and the button changes color. We can do that on each switch. But in doing that, then the reset wasn't working correctly. So when I applied power to this, all the lights were coming on, which was an issue I was having before. And that's how we got this capacitor and this resistor in there. But now that everything's hooked up, it got more sensitive and this capacitor wasn't draining. So we had to put a diode parallel in the row of the resets. So they're different on each side, and then to ground. So when this thing powers off, it drains the capacitor. And now I don't have any issues. So you can see I turn the power off, I turn it back on. And these loads aren't on, which was happening. So we can see here it takes a second before it starts working. So when I removed the diodes to try to show what was happening, it didn't happen. So I had to find an old clip, and I have one here of when it originally happened. So you can see power's coming on and all the lights are coming on. That's what we had to fix. Okay, I wanted to show the difference here when I built this original one and the 4 relays. And this one here, you can see they're both standalone, so I don't have any wires connected here. This is the portion that would be going to the Teensy, the microcontroller. So I have those disconnected. So we're just working off a 12 volt right now. And on this one, I just had 2 separate buttons. So you can see I could turn it on from here and turn it off from here. And then this one I had connected to the Teensy and 1 manual button. So it's easy to parallel a bunch of buttons on. So the big difference here is that on the reset, originally I didn't have to have a capacitor and a resistor on one side. And then eventually I did. And on this one, I eventually had to put in diodes. So you can see here, there's the resistor, there's the capacitor, there's the diode. They're all in the reset pin row. So what I've discovered is that, so I removed these and the lights didn't come on. So these things are really sensitive. So they can be sensitive to different voltages or temperatures. And so you can see right now, this is on. If I turn the power completely off, I turn the power back on, the lights aren't coming on. Like we showed in the previous clip where you saw all of these coming on. So you can see here, these are all working independently. So if you just wanted to make this project, you could. You don't have to connect it to a microcontroller. So I just kind of wanted to show the difference from what I did here and here. So there's 3 components on the reset pin here. And it's probably better to leave these in. So that's why I put the diodes back in, because I don't know what this situation is going to be like the next time I turn this thing on. So I want to be assured that these lights are not coming on power up. So I'm thinking doing a diagram of all 4 circuits is going to be pretty messy in here. But we can show that we're coming out of pin 5 here to trigger this transistor. That's how it goes to ground, and that's going to go through here. So this is connected internally on this button. Okay, so this will send ground to this chip here, just like the button. So if we push this button, it'll go from here to here, sending ground to this button. And then this over to here, I should say. And then we have the 1K pull-up resistor, so that's putting positive on this to ensure that it doesn't do anything until it receives a ground signal. And then it'll come out of here on this particular circuit we're talking about, go to 13. And then it comes out of 15 here to this trigger this other transistor through the 1K, and then puts ground to the coil. Positive is already here on the other side of the coil, and then this would close from the common to that normally open. That would be closed through the resistor and turn on the LED. But this also, before the resistor, I've got 12 volt tapped in to this voltage divider. So this is the positive side, this is the 47K, this is the 12K. 12K goes to ground, 47K goes to positive. That's hard to see here. That's going to here. And then we have a 104 capacitor here to keep this steady. And then that goes out to pin 27, and pin 27, when it reads that voltage there, that's when it changes the color of the button on the display. Now over here, here's the important part that we had to change. Normally we would have a 10K resistor going to ground on the reset pin. And then a 105 capacitor. Oh, this is a 104 capacitor. The 105 capacitor is over here. This is a 104 capacitor, and then I had to put in a diode so the stripe is facing ground. Every time I use that type of diode, which is the, I think it's a 4148, this little one here. I don't know if that'll focus, but chat has me put it in backwards every single time. So I turn around and it starts working. So that's what's going to keep this reset working. So previously I didn't have diodes here because it was working. Now that all this stuff is connected, now I need this diode in here. So that's the main change that I made from the previous video. And then we have the 105 is connected to the input of this chip here. This is the, I think it's a 10406. These are 4027 flip-flop chips. So that's the big change I had to make, was add that diode when I connected all 4 of the relays. And as you saw previously, it's working very well. Really happy with it. Okay, so here's all of it, and all 4 of the circuits, the buttons, transistors, the voltage divider so we could read when these are triggered. I know it's a mess, but I'm going to try to explain it anyways. So the previous diagram, we're just repeating it over and over, right? So from your teensy, you have pin 2 in, pin 3 in, pin 4 in, pin 5 in, and they're controlling their own transistor, which is controlling its own part of the chip up here. So like I said before, out of this transistor goes to the button, and this part of the button is connected to this side of the button. So you can follow the path, the ground. We go from here to there to here, through here, through here, and then over to this pin. And if you press the button, the ground would go from here to here, and then over to the same pin. This 1K is just keeping this positive, so it's pulled high because it's waiting to see it get pulled low, a negative or a ground signal here. Then that outputs over to here, which is the clock, and then the clock will change Q, and then that goes to the coils like we explained previously. But just wanted you to see that's just repeated over and over and over. Okay, just depending on where it has to go on these chips. And then I'm going to post this in the description, but this is kind of a mess here. So you have this is the reset pin on this side. The reset pin on this side is 4. So you see they don't line up because of where the power goes in. So the power goes in, the ground goes in at 8, and the positive goes in at 16. So that shifts each side. Otherwise, they're the same. You're still going to have your reset pins connected this way. That's why I just drew 3 lines here. 3 lines equal the reset pin. So you have the 10K goes to the ground, all in parallel right here. And then your capacitor, that's a 104 capacitor, goes to positive in that same row. And then our diode ground in that same row. So what's happening is when we turn on the power, the capacitor is going to charge. This takes like, I think, a millisecond for all this to happen. It's going to put positive on here briefly. And then once this charges, that's when the resistor takes over and puts ground there. That keeps these lights from turning on power up. And then when we power it down, this diode is going to drain this capacitor, ensuring that the process will start over. And then you can see here, like on this inverter chip, so I put 2 YB, yellow button. So this line would be going to the yellow button where it says here, pin 3. So this connection here is like this connection going to the chip. But I didn't want to draw lines all over this thing, so this one to yellow button right here. Same with the red button. That's going to go here to pin 1. The other ones I did weird was like pin 24, 25, 26, and 27 to the teensy. So that's what's going to tell us when these lights are on to change the color of the button on the Nextion. So here I have this one connecting to A. So we find A here, that's controlling this one. So when this side gets power, this light turns on, it's going to put power to here A, which there would be a wire connected from A here to A here. This is the positive side of a 47K resistor. The 12K resistor goes to ground, and in the tap we have a 104 capacitor going to ground, and then also at the tap here, that's where it's going to go out to your teensy pins. And you can see that's just repeated, I should say, again and again. So your A, your B, and your C. So these connections are before the resistor. So it's going to send 12 volts out. It's not going to be reduced like it is going to the LEDs. And in a real world situation where I'm trying to actually trigger a light inside of an RV, let's say, I might not be using these relays. These are 2 amp relays. I'd be using something bigger. I think I would go like a 10 amp relay, just a CYA, and then it would actually go out to your light or your water pump, whatever you're using. So these would get sized differently. And then next I think I'm going to do a little bit more explanation on these chips. The longer I mess around with these things, the more I understand. And just know I'm not an engineer, I'm a hobbyist. So I'm going to do my best to explain these. So if you're a hobbyist and your first time, playing with these things, you can understand what's going on. Okay, the 40106, that's the single chip. We have two of the other ones. So you can see pin 7. This tells you where pin 1 is. So when you see this, the top left one is your pin 1. This is where our ground comes in, so our power for it. This is where our positive. This chip can handle 3 to 15 volts. We're using a 12-volt system, so it gives us around 13 something volts typically. And then all you can see here is a bunch of in and outs, in and out, in and out. And there's actually 6 of them. So don't confuse the pins with the in and outs. So you can see this is 1, 2, 3 on this side, 4, 5, 6 on this side. And we're only using 4 of these in this particular project. And so this thing does basically 2 different things. One thing, it's an inverter chip, so inversion. And it's going to output the opposite of the input, right? So if we put high in the input, it's going to output low, right? So that's one thing it's doing for us. And the other thing is it's signal conditioning. So it's going to ignore tiny little voltage fluctuations so that the output switches crisply. So when I was trying just to use a flip-flop chip before, it wouldn't work. It wouldn't be consistent. And that's when using ChatGPT, it told me I needed one of these chips. So got one of these, and then it took a while before everything started working. I worked on this quite a while before we got it straightened out. But basically what happens is, and I don't know the exact numbers of what we're using right now, I'll give you a for instance, like it'll turn on at 2.8, but it doesn't turn off until you get below like 2.2. That's like an example Chat gave me. So it doesn't just turn on and off at 2.8 and then 2.7 it turns off. There's a little gap in between that helps keep this clean. So like a mechanical button, which could be very noisy to these electronics, it filters that out. Okay, so now here's the other chip, the 4027 flip-flop chip. See, we have our half circle here. So this is pin 1 here, the top left. And then we have our ground coming in on pin 8, and then our positive, this one's 3 to 18 volt, goes here on pin 16. So that's what shifts these around. So you can see like our set is not in line with our other set. See here, they're a pin off. So that's what I was talking about earlier. But if we start here, you have 2 Qs, so 2 outputs. So this is Q and this is not Q. So whatever this is doing, this one does the opposite. So in this situation, we're using pin 1 and pin 15. Those are our outputs to the transistors that control the relay coil. Clock is the input coming from the 40106. Okay, so on this side it's pin 3, but on this side it's pin 13. See, they're just not across from each other. So just be aware of that. Then our reset, 4 and 12, that's where we have the resistor, the capacitor, and the diode all connect to this pin. So when we turn it on, then it doesn't trigger our relays right away. And then our K and J, we connect positive to both of these on both sides. That's going to tell this thing to act the way we want it to. and then our set, that gets a ground signal. So set here and set here. I made this video because things kind of changed when I tried to do all 4 latching relays. So each button had its own latching relay, where I was just doing one just for proof of concept before. And so that reset thing started acting up. And I've had that issue the whole time I've been working on this project. Once again, I'm trying to learn how to do this. And once I added the diodes in there, then that cleared it all up. Even though I pull the diodes out and I can't reproduce the problem as it sits right now. But I think, you know, those chips and these electronics can just be finicky that way. So I just wanted to show the difference from the last video and what I did to have to make the 4 latching relays, because you would think you just repeat the process. It's working now. I'm happy with it. I'm not sure what I'm going to do next. I've got some other kind of related projects I'm working on, but I also want to work on a phone app that connects to this project so you can turn the lights on and off from your phone. I don't know if I'll be able to do the other way with the monitor panel and all that right now. I just kind of want to get the buttons working. So that's what I'm going to probably work on next. Anyways, thanks for watching, and we'll see you next time.